Hi, Great Friars community. We are on week 4 science. High five. I'm so excited. Last week we talked about the states of matter. Do you remember what the states of matter are, Holly?
Solid, liquid, gas, plasma.
Yeah, did we put it to a song?
Yes.
Yes. Solid, liquid, gas, and plasma are the states of matter. Solid has definite shape and volume. Liquid has no definite shape, but it has definite volume. Gas and plasma have neither. Solid, liquid, gas, and plasma are the states of matter. Fist bump. Nicely done. We learned that just because solid has definite shape doesn't mean that it can't be changed, right? We saw that applying a force, like crumpling up the paper or tearing it in half, or causing a chemical reaction, like setting it on fire or pouring an acid on it or something like that, mixing it with another substance. We'll study those things later, but those can change how the atoms act, and the electrons in particular, right? We talked about how one element or molecule can exist in the different states of matter. Like water is the most common example. You can have ice, that's solid water. You can have water, that's liquid water, H2O, and then steam, or water vapor, that is the gas. As we go from one to the other, the atoms can get excited and the substance can change, right? We talked about how metal can be melted, right? We can have solid gold, but then they melt it at a certain temperature into a liquid form so that they can pour it in a mold and make jewelry, right? Things can also go the other way around, whereas a gas is cooled, it can turn into a solid, right? Go liquid solid. Kind of like when you put water in an ice cube tray in the freezer and it becomes ice, right? Remember from our look at the periodic table that each atom has an atomic mass. Do you remember that? How it had lots of numbers. Each little square in the columns and rows has tons of information that tells us about the qualities that make that element. Even though they are very, very tiny, protons, neutrons, and electrons have weight, don't they? They have mass. Remember we said protons are positive and heavy. Neutrons are neutral and
Heavy.
Electrons are negative and
Heavy.
and light, right? But even though electrons are it takes 1,800 electrons to equal the size of one proton, there's still some mass to them, right? If you had enough electrons, it could weigh something, right? So they contribute to the mass of the atoms. Mass is the amount of matter that an object contains. Can you say that? Mass is the amount of matter an object contains. I'll teach you guys a song in a moment. I forgot how it went. But mass is the amount of matter an object contains. Mass is the amount of matter an object contains. Maybe chant it a few times and then it will stick for your memory work. How does mass compare to weight, Holly? Any ideas? We'd say that it's the amount of matter. It kind of makes it, you associate it with how heavy something is. And weight has to do with how heavy you are. Do you know what the difference is?
Yeah.
No? Okay, so weight, let's say if you step on a scale, does it give you your mass or your weight? When you step on a scale,
Mass.
Holly, think about this. Don't be staring out the window. When you step on a scale, it's measuring your weight, right? If you stepped on a scale on the moon, would you be the same weight?
Yes.
Do not look at other things. I want you to pay attention, and I want you guys at home to be paying attention. Don't passively watch these videos. When I ask a question, you try to think of the answer as well. Holly, if you stepped on a scale on the moon, right now we step on a scale on the earth. If you step on a scale on the moon, do you weigh the same amount?
No.
No, it would say you weigh much less, right? If you stepped on a scale on Earth, but on top of a mountain, when the moon is overhead, would it stay the same weight as when you're here?
Yeah.
No, this is the key. Your mass, okay, I should be careful with how I say this. Your weight changes based on the gravitational force. Earth has gravity. It's pulling you towards the center. It keeps you from floating off into space. Your weight is a function of your mass and the pull of gravity, okay? If you are on the moon doesn't have as much gravitational force, so you would weigh less because it's measuring your mass and the pull of gravity. On top of a mountain, it may not make a huge difference, but you're further from the center of the earth. So technically the earth is pulling slightly less at you. And if it's at night and the moon is overhead, the moon is technically pulling you slightly up towards it. And so your weight would be different. It would be negligible. It's not much different, but your weight changes with the gravitational pull. So weight is a measure of how gravity pulls down a mass. So now that we have an idea, what is mass, Holly?
Mass
is the amount of matter an object contains, right? So thinking about mass, let's consider this. If we had a pillow fight right now, that would be pretty fun, huh?
That would be best.
We never want to get in a pillow fight with Mr. Campbell, though. Man, if he wanted to, he could go. Which would you rather be hit with during a pillow fight? A pillow stuffed with feathers or a pillow stuffed with bricks?
With brick.
Oh, you're crazy! Crazy! No way! Okay, anyone who is not being crazy would say they would rather a pillow stuffed with feathers, right? Because I definitely don't want to get hit with a pillow stuffed with bricks. Okay, so now let's think about it. If you were having a pillow fight with a giant, okay, and he has
like in Frozen 2.
Yeah, oh my goodness. Would you rather be hit? What would you rather be hit with? A pillow stuffed with 100 pounds of feathers or 100 pounds of bricks?
Let's fight with bricks.
No, he's just being so silly today. So, Mr. Camel, I asked him this question, and he said, I think I'd still take my chances with the feathers. Like, even if they both weigh 100 pounds, he's like, I'd rather try the feathers because bricks definitely would not be fun to get hit with. Why? Why is that, do you think? This has to do with density, which is the main thing we're studying today. Density is mass over volume. One way you can forever remember this. Think of a really densely populated city with lots of traffic. Dense traffic, think of DMV. Your mom will never forget it now. DMV. Density is mass over volume, okay? Density is mass over volume. Can you say that? Density is mass over volume. Density is mass over volume. Say it a few times, you guys. So which do you think is more dense? A feather or a brick?
A brick.
Ah. You know what though? It's not that easy to guess density. Because to calculate density, we have to measure the mass of an item, which we can do that by weighing an item on a scale and then dividing by the amount that gravity is pulling down on it, okay? Or accelerating the item. How do we figure out volume? Do you have any ideas? How do you figure out the volume of a feather? Okay, if I have a cup of water and I have a measuring cup, right? That's pretty easy. I can figure out the volume of my water. But how do you figure out the volume of a feather? If density is mass over volume, we need to know what the volume is. How do you think, Holly? I have an idea. You guys stay here, and I'm going to tell you about this. I'm going to grab some water. Okay, here's some water. And Holly, will you grab, is there a Lego brick still down there?
No.
Okay, I'm going to fill up a cup measure with some water. Let's try to get it as precise as we can. Let's say Oh man, not precise. It's just above the 1/2 cup measure. Okay, if I wanted to measure the volume of a crayon, let's say, okay, there are certain ways that you can measure the crayon, but once it gets up here, then suddenly it might be kind of hard to measure its volume. But watch, if I drop it in the water, oh man, that didn't work out. Let's find something smaller. Can you find a brick for me, babe? Go find a brick. Or can you hand me one of your rainbow loom bracelets right there? The ones that you made, the full one. What is the volume of this rainbow loom bracelet? Here's our trick. Archimedes came up with this idea. The king had a goldsmith make a crown for him, and he was convinced that the goldsmith had cheated him and not used gold through the whole crown. He thought that he had substituted another metal, and he put Archimedes to the task of figuring out how to prove that the crown was not all gold. Okay, look at me, not at the screen, okay? So what he did, Archimedes was trying to figure this out. And one day he got in the bathtub and suddenly the water overflowed the top. He said, aha. And he was able to use that to figure out the densities of the metal and how much should be displaced if it's all gold. So if I want to figure out the volume of this, I can take my cup of water, my 1/2 cup of water, dunk this in, and then see how much it changed. Obviously, this one is not very precise, but that's why scientists have beakers that have very precise measurements that allow you to take measurements of something that would otherwise be very hard to measure. Pretty cool, huh? Okay, so let me see. How do we determine the volume of a feather? We can use a test like that. What units do you think we measured in?
Don't know.
It's different things. So some are like grams per cubic centimeter is an example. But it's based, anything that's volume has to do with cubic space, okay? You'll learn more about that as you get older for math, but just file it away for right now. Let's pretend I have a rock and a ball, okay? Let's take a heavy rock and then one of those balls that are on clearance right now at the store, right? Those little rubber balls.
Yeah.
And I drop them both into water. Okay, if I drop a huge rock into the water, what's gonna happen to it? Where's it gonna go? If I dropped a rock in here, where would it go?
It becomes.
Holly, think of this. If I dropped a rock right now, what would happen?
It would dissolve.
No, I'm gonna pause the video for 1 moment while we grab will you go and grab one of your rocks from your playroom?
Okay.
Okay, so we have a little rock, pebble. If I drop it in the water, what's gonna happen? Let's watch.
It will drop.
It goes straight to the bottom, right? If I had something like these rainbow looms or a balloon or a rubber ball, what do you think will happen? Will it drop to the bottom? Wait.
It will.
It did just a moment ago. It did not. There. It floats, right? I don't know what changed about how you threw it down there, but it floats. So what does this tell us about it? The rock is more dense than the density of water. The rubber bands are less dense than the water, so they float. So by testing things this way, we can compare densities, which tells us properties about things. Why do we care about densities? Can you think of some reasons? Mr. Campbell has been mixing concrete for our deck, okay? If we have a more dense wood, for example, why is pine less expensive than cherry wood? Cherry wood is denser, it's harder, it's sturdier, right? Whereas pine, you can pretty easily break off chunks of it. But that doesn't mean we don't use pine. There are definitely things that you're gonna use pine for. We used some pine on part of the bed you made for your baby doll. So depending on the density, it will have different purposes. Some things are more porous, meaning things can seep into them or seep through them. That could be good, that could be bad. Some things are more dense, which makes them heavier, which makes them sink down. If a ship had an anchor that's not dense, would that be very helpful to it? No, you want a dense anchor that will sink down to the ground and hook in and hold the ship in place. Sometimes density affects the cost of a project. Like Mr. Campbell was pouring concrete this week. There are some places where you want really dense concrete to hold it sturdy. Like if I was building a skyscraper, would I want a not so dense concrete as the foundation? No way. You want to make sure that that concrete is going to be dense with no gaps so that it won't change over time. For our walkway, we probably don't need it as dense. Also, density affects how things mix and interact. It affects airflow through around and through an object. It can be more compressible or more rigid. It might affect whether you can see through something, translucency. If I'm making plexiglass, do I want it to be so dense that it's opaque and then I can't see through it? Maybe. If I'm using the glass for a shower, I might want privacy. If I'm wanting it to trace maps underneath, then I probably don't want it as opaque. It can also affect how it absorbs things. You guys, some of you might not care, okay? I want you to at least appreciate why it's important to understand density and how it can help you in the future when you get to high school and need to figure out science experiments, or you want to enter a science fair and win. You should have an understanding of these things so that you can make experiments and test things well, okay? We want to do all things well because it glorifies God, right? But some people are naturally wired to care more than others. And if you're an engineer, you're definitely going to have to care more about this than if you're an English major. But if you're an English major, someday you may homeschool your kids and have to help them through science fair. So you guys try to learn this and learn it well. What is density? Density is mass over volume, right? DMV. And what is mass? Mass is the amount of matter an object contains, okay? So I'm going to show you guys density. More dense things do not always sink. There are a few examples, and I'm going to post this on the website. There are a few elements and molecules that are less dense in their solid form, okay? Ice, for example, right? Ice is the solid form of water, but does it sink or does it float?
It floats.
It floats, right? You guys, this is a good chance for you to study, practice your math skills. You can see why it's important to be good at math, even if you're studying science, because it can help you compare these numbers to see which ones are bigger or less, okay? We're gonna do some experiments now really quickly, and you guys can try the stuff at home. I want to remind you, do not mix random things, okay? I'm doing these experiments with things that are already tested, and I know how they interact with each other, so I don't have to worry about a chemical reaction that could harm me, okay? Also, always be in the habit of using safety gear. Even though I know that there is nothing here that will react in such a way that it could splash into my eyes and cause burns or otherwise harm me, it's a good habit to be in. So Holly, you and I are going to put on our safety gear before we get started. Do you want to wear the shield or the goggles? The shield? Okay. Good idea. My brother, I've told some of you that my brother had a battery explode in his eyes doing something that he normally did and normally never had problems with. And we suddenly had to be very scared that he might go blind, right? So always be careful. Can we tell?
He didn't say that.
Yeah. So you guys, I have a few things poured here. Notice, do these look pretty similar, Holly?
Yeah.
Can we tell anything about their density just looking at them? Do you think that any of them would be more or less dense, or would they be about the same?
About the same.
Yeah. Let's see. I'm going to show you guys in an experiment. I'm going to pause the video for just a moment, and then we'll try this again. Okay, so here is our first density experiment. You can do this with a glass, any kind of glass cup or anything you have at home. We also have some of these from Dollar Tree. You can also buy science supplies at like Hobby Lobby, pretty cheap. But really, you can use whatever you have at home. We are going to start out with honey. then do corn syrup, then maple syrup. Notice this is the real maple syrup, not the stuff that's made out of corn syrup, okay? And then we would have whole milk, but I realized that at home we only have 2% milk, so I'm not sure that it has the same density. Holly, would you mind turning out these lights so that we don't have that glaring light right there? And then we use Dawn dish soap. No, not this one, the one over there, babe.
Oh.
And then water, regular water. Not both of them, please. Turn on the one over there. And then some vegetable oil. I have canola oil at home. I do not know that it works the same. So you can try it out and see. And then our last one would be rubbing alcohol. I'm doing small amounts of these because I don't like wasting food and especially wasting rubbing alcohol. Hallie, would you mind switching the lights that are on? Have those ones on and the ones overhead off, okay? Thank you.
These ones on?
Yep, switch them. There you go, perfect. Okay, I'm gonna start out with our honey. I'm gonna pour it directly into the middle, trying to avoid the sides. How dense do you think honey is compared to other things? What would you guess, Holly?
I would guess that it is.
And I'm using little cups. If you want to get everything out, you can have a little spatula on hand. But just make sure it doesn't touch the sides because that can kind of mess up your experiment.
What are we doing?
Okay, we're gonna see. I'll show you. Okay, so there's honey. Our next step is corn syrup. Okay, let's see how this one pours. Okay, there we go. What do you notice, Holly, so far? Can you guys see?
That it's
on your
changing
screen?
colors.
Ooh, but notice, is there kind of a line between them?
Yeah.
Yeah, kind of a line between them. Are they mixing automatically when I pour them in?
Yes.
So you guys notice, if I wanted something to mix, but it has different densities, what does it naturally want to do? One of them will float on top of the other one. So if I wanted to mix them, I'm gonna have to stir them, right? But that's not what we want for this experiment. Next, we're gonna do the maple syrup.
Can I do it?
Yeah, I'll have you, how about, can you do, yeah, let's just pour it straight in the middle. Ready? Pour it straight in the middle. Notice it's dropping down, kind of in the middle, right? Do you want to finish pouring it? Sorry, I kind of took over. I didn't mean to, babe. So it kind of dropped down when we first hit it, but watch what happens. You see how that middle part is kind of rising? So do you see the 3 lines so far? Okay, so what does that show us? Which one do you think is the most dense?
I think
The first, the second, or the third?
the second. The third, I think.
The first one is the most dense. Okay, let's keep going. I would put in the milk next, but I'm not going to. Instead, we're going to do the Dawn dish soap next, okay? And this one I'm also going to pour on the middle. Okay.
Mixing.
Notice as we get more liquidy, notice how easily this one pours compared to the first two. I don't need to use my scraper as much, my spatula. Pretty blue, huh? And notice how it automatically delineates between each layer.
Yeah.
Okay, for my next 2 layers, so I have some water and some vegetable oil, and then we have rubbing alcohol. I'm gonna add some purple dye to my water, and I'm gonna add some green dye to my rubbing alcohol, just so we can really tell all 3 layers apart, okay? So I have some purple dye on this one. Now what we're gonna do, babe, we're not gonna pour this one. We're gonna take it up with this. You can use a turkey baster, or these, they sell in the stained glass section of Hobby Lobby, I found out. We're gonna squirt it, don't squirt it yet. Listen to instructions first. Science, it's important, instructions are important, especially in chemistry. Keep that on. You're going to squirt it on the side. Don't squirt it in the middle, okay? Do it really slowly. Really slowly. Do you know why I have her doing it really slowly? because you don't want the force of the liquid to mess up how it mixes together, right? I'll do one and then you can do another one, okay? Let's see if we can get it. There we go. Gonna do another one. Squeeze it really gently. There we go. Can you guys tell the lines a little bit on your screens?
Yeah.
I'm gonna keep doing it a little bit more, get some more, so you can really see these lines. You guys can do this at home. Just make sure that you find a recipe of things that are safe to mix. I've also seen some that use chocolate syrup. One thing, you can use this to kind of test which syrups are more dense. Like some people like a really thick syrup that you might use for different kinds of recipes, right? Okay, now I should rinse this out, huh? Okay, I don't have another syringe, so I'm just gonna use this one again to pour in our vegetable oil. Watch this, Holly. What do you notice happening?
Oh, it's getting straight.
That's pretty cool. Can you guys see that? I'm gonna see if we can pull the camera up so you can watch what happens. Okay. Sorry, I'm trying to aim it at this. You guys see that? It kind of spreads out. Pretty cool, huh? Sorry for the big thud as I'm setting it back down. All right, let's finish adding our oil.
Oh, it's getting down. It's going down.
Wow. Our last little bit of this is our vegetable oil. So what does that tell us about vegetable oil compared to corn syrup or maple syrup?
That it's very dense.
Yeah, do you think those things want to mix? A lot of times, like when you have water, so the purple part is water and this part is vegetable oil. And a lot of times recipes will call for water and oil, but they don't want to mix. So what do we have to use with them to get them to mix? That's when we use a whisk, right? Or you can add another ingredient to help them mix, right? Okay, don't shake it at all, babe. That will mess up our results. Okay, last little bit. We're gonna add the rubbing alcohol. I'm gonna see if I can pour it very gently on the side without messing up our layers.
Then you should then use that.
Uh-oh, I didn't mix the colors well enough.
Wow.
So my green dye is kind of wanting to mix. That was a good lesson learned. I should have made sure that my green dye was really in my rubbing alcohol before I added it. Because now it's my green dye is kind of sitting with the vegetable oil and you can't see the top layer as much. Kind of neat though. We made like a rainbow in there. Do you see that? Each layer has its place. So why do we care about density, Holly? I was thinking today, have any of you gone to a restaurant where they give you one of those cheap packs of crayons? Have you ever had that?
Yes.
Those crayons don't color very well, do they? No, they are never as good. There are lots of times that I want to buy the Crazy Art crayons because they're cheaper than Crayola. But are they as good?
No.
When you really want to color something really well, does the Crazy Art brand ever color as well as the Crayola ones do?
Yeah.
Does it? No, it doesn't. So I thought, is there a way of proving whether there's more density, like more compact wax and color in the Crayola crayon? And what we could do if we wanted to test that is we could take different brands of crayons. We could take our Crazy Art blue and our Crayola blue and maybe one from a restaurant and put it in a liquid and find a liquid where the Crayola one floats and then try testing the other ones to see if they also float or if they sink. Or I guess you would want to see if the Crazy Art one floats and the Crayola doesn't float. But it would help us to see the density of the material in it. Granted, that won't always tell us whether it's actually a better crayon, but it might be a cool experiment to try. So, okay, I have another experiment for you guys. Holly, will you please go grab 2 eggs from the refrigerator?
Okay.
And I'm going to take these 2 glasses of water.
And sugar.
I am very thirsty. Are you guys thirsty? Should we drink this water? No, we need it for an experiment. While Holly's getting the eggs, can you guys remind me, what is density? Density is mass over volume, right? Density is mass over volume. And what is mass? Mass is the amount of matter an object contains. Can you guys remember from our previous weeks? Let's do a quick review. What is chemistry? Chemistry, what is chemistry? Chemistry is, what is chemistry? Chemistry is the study of matter and how it changes. And then what are the parts of an atom? Protons are positive, heavy. Neutrons, neutral, heavy. Electrons, negative, light. And then we said, what is an element? An element is a pure substance that cannot be broken by chemical means, right? And then how many elements exist? 118, okay? And then last week we learned that there are 4 states of matter: solid, liquid, gas, and plasma. Okay, so Holly, you're gonna break an egg in there and I'm gonna break an egg in here. We're gonna discuss.
Wow, it's sink. Yours
Wait,
Mine?
yours sank and mine floated. Wait a second. We had 2 eggs, so there has to be one explanation. It has to be an explanation for this. Either there's something different about the eggs, or there's something different about the water, right?
Yeah.
So one thing that's neat is that I tricked you guys. I actually added salt to this water. Salt water. If you go to the Dead Sea, did you know you can float? Or even the Salt Lake, I guess it's the Great Salt Lake in Salt Lake City. You can float so easily because there's so much salt. So the water becomes more dense as there's salt added to it. So this egg floats, whereas in normal water, this egg sinks. If you want to try something really fun, you can make your parents baffled. You can put have salt water. Okay, so I'm gonna dump out a little bit of salt water out of this one. Oh man, darn. Didn't mean to do that. I lost an egg, you guys. Holly, will you grab another egg for me?
Okay.
Watch, actually, I can probably have to, you can stay there. I'm gonna be right back. Let's see. Okay, I'm gonna see if I can salvage this egg. Okay, so I have my salt water. I dumped some out. I'm gonna gently pour this egg into this bowl. Okay? See how my egg floats? Guess
And
what?
it looks like the
Now,
sun.
check this out. Okay, I'm gonna pour regular water on it. And watch what happens. We're really careful to not mix it.
That parents, no.
No, I'm just talking about so that the salt water doesn't get mixed with the fresh water. I'm gonna pour it really gently. And look, suddenly I have my egg suspended in the middle. There's salt water below it and fresh water above it. You can challenge your parents and see if they can figure out how you made the float, how you made the egg suspend in the middle of your cup. Have fun. I'm gonna post some other experiments you can try at home as well as some crafts. And I will see you guys next week. Bye.